Thanks for the chance to speak to all of you in this, let's say, special situation. I very much like the idea of this virtual conference, and yeah, it's an interesting session for us. So, Kevin, I think you are going to take care of the slides, right? So,
Yes, I will.
Okay. So basically, I think if you go to the next slide, so the topic which we want to discuss today is a hybrid approach in terms of tackling fraud management and risk management. So therefore, in this session, Kevin and myself, we would like to share some of the experiences we at Inform have made using artificial intelligence techniques in the area of fraud prevention and risk management. In particular, we would like to elaborate on why we decided to make use of a hybrid AI approach, what it basically is, meaning by combining knowledge-based methods like rule sets, fuzzy logic-based scorecards, dynamic profiling techniques, in combination with machine learning-driven models. And this in order to detect fraudulent behavior and prevent fraud losses for our clients within the financial sector, as well as in the telecommunications or the insurance area. Therefore, in the following 40 minutes, we would like to emphasize on how we make use of the hybrid AI approach within our strategic risk management and fraud prevention platform, RiskShield, which I think Jan and Mike also shortly touched upon, and why we decided to integrate BigML as our machine learning platform into the overall offering of our solution. But before going into deep to these areas, let me first start with giving you a short introduction to Inform as a company. So basically, who we are and where we excel in. So Inform, the name stands for Institute for Operations, Research and Management. So we are a company which has been founded already 50 years ago, at that time as a university spinoff. And our focus was and still is to enable our customers to make better decisions based upon data evaluation and analysis. Today, we are happy to state that our software solutions are being used in more than 1,000 institutions across multiple industries in more than 40 countries. To give some examples, if you take a look at the pictograms below, for instance, all major airlines and airports are making use of Inform software solutions in order to optimize ground handling processes in an efficient manner and with the scope of focusing on how to deal with unexpected situations or interruptions within the normal workflow. For instance, just imagine the impact on the overall process chain at an airport in case there is an emergency situation at an airplane and you need to quickly rearrange and prioritize the landing order. Think of all the affected processes and sub-processes, like rearranging parking spots, personnel required at the gate, rescheduling, baggage, cleaning services, and catering services, and more. And all of this you need to do in real time, basically in a couple of seconds. As we can all imagine that for a human operator, this can become, let's say, a huge task. We are, let's say, in the need of the support of smart software solutions. The same goes for, let's say, the highly on-demand optimized production industry. What to do if, for instance, one component within the production chain is missing? Are we going to stop all machines and wait until all components are available again? Or would you try to replan and prioritize certain tasks in order to make use of the unplanned available capacity at the machines currently not in use due to this unforeseen situation? Again, I believe that we would all agree that we would go for the latter option. But we also know that the execution might be not as simple as it sounds, at least without having assistance by smart software solutions. And as you can see below, there are much more areas where the overall complexity became too huge for a human only to handle, such as transport logistics, human resource planning, and more. The area of focus, which Kevin and myself are representing, is the risk management and fraud prevention area. An area which is defined by its highly dynamic and adaptive nature. If you, for instance, close one door for the fraudsters, they are going to adapt, finding other vulnerabilities in order to come back in again. Just think about the magnitude of possibilities for credit card fraud, internet and mobile banking fraud, money laundering schemes, and more. So, um, Kevin, if you go to the next slide. Um, so basically, if you want to find these kind of holes, tracking them by detecting anomalies within the data. So this has become more and more challenging for human operators over the last years. So basically, it's about taking the right decision at the right time, taking into account all the information available. Again, let's think about the very straightforward example of card-based fraud. Most of you will have heard about modus operandi like skimming, for instance, where fraudsters make use of small devices to capture the details of the card at an ATM or point of sale device. Of course, in order to make use of this data in a fraudulent sense afterwards. The challenge for the analyst will be to detect these fraudulent payment initiations amongst all the other legitimate ones and to directly stop them in order to prevent damage for the cardholder. This means the analyst needs to be enabled to create rule sets and models which allows to analyze all incoming transactions, filtering only those out who are untypical for the underlying cardholder. And contrary to other areas like, let's say, e-banking related fraud scenarios, there is no way in a card-based sense to put a transaction on hold or to call up the cardholder while initiating a transaction. So there's no way that you can say, okay, there is something, we need to call up the customer, verify if he or she is the one who is currently initiating it. You basically need to decide in that split second if you want to decline the transaction or not. This means all decisions has to be taken instantaneously in split seconds while having a pinpoint accuracy. If you go to the next slide, I think now when we take a look at the payment ecosystem and what we all experienced and are experiencing, let's say over the last years, 15 years ago, when people talked about digital payments, they had card payments in mind. Risk managers at that time had already a challenge in defining rule sets and scorecards, overseeing the activities in this one straightforward, simple channel in order to track the interaction between customers and the bank. Later, when people started using more internet and mobile banking related payment services, risk managers were in the need and also saw the chance of using cross-channel monitoring in order to detect fraud with a good hit rate and a low false positive rate. Meaning, they were suddenly addressing questions like what likelihood of the current card transaction in an abroad country, for instance, being fraudulent, especially when we see that the cardholder logged in into his e-banking account using his usual IP address an hour before. So it was about making use of the data available, making cross-channel checks, or how we call it, make a contextual analysis to bring context to one transaction by taking data from another channel. And basically, this is what our software solution RiskShield is offering to our customers. If we now take a look at the situation today, where we as customers have more interaction and payment initiation possibilities like ever before, speaking of the means of PayPal, Apple Pay, Samsung Pay, Garmin Pay, Fitbit Pay, and so on, each of them with their unique strengths, but also unique weaknesses, this is becoming a huge challenge for the risk managers and analysts fighting fraud each day. When we now go to this next slide, I would like to elaborate a bit on what does it mean exactly. So basically, This means that today the issue is not anymore about the non-availability of data like it was in the past. Today we have got more data than ever. So it's about the huge amount of data available and which also needs to be considered whilst evaluating the risk of a transaction. Today we have got so many data points available which can and should be used in order to judge if the pattern we see fits into the normal behavior of the customer or not. This can, for instance, start from the way of logging in, the authentication method used, the time of interaction, the payment method used, the relationship between sender and beneficiary, and more. If everything fits into the normal behavior, the transaction will be scored low and naturally will be let through. If we go to the next slide, um, this it might also happen that while evaluation of the transaction, there might be deviations from the normal user behavior, which of course then can be detected and be used to stop the transaction and prevent financial damage for our customers. Then what we always see is that the fraudsters they will always try to mimic the most of the aspects of the customer like they can. Today, if you take a look at the darknet, it's not only about selling fake card data or let's say stolen card data, like what is the card number and what is the CVC code and so on. No, you can buy much more details of a customer, like what is the user, what is the browser being used, so the user agent string, or what kind of operating system is he or she using, from which IP address are they typically acting, and much more details. But at some stage, all fraudsters want to make money. So at some stage, they are going to use, for instance, an account never been used by the customer or any other customer of the customer base of the bank. They are going to make use of browsers where we know that they are vulnerable for certain kind of malwares. They will make use of certain kind of actions at time frames where it's, the likelihood that the transaction will be initiated faster will be higher. So there will be always some data points which we can make use of in order to filter out riskier transactions from the, let's say, more legitimate ones. So if you go to the next slide, this means that in order to detect these deviations, the analysts need to be enabled to analyze given data sets and to find common spots in the data leading him or her to the underlying modus operandi. Whereas this might have been already a tough task in the past, the rising amount of data which needs to be considered makes it nearly impossible for a human alone to handle. And here, the additional use of machine learning can help the user to find the needle in the haystack. If you go to the next slide, there's something which we want to mention again. What I said is here we see that the additional use of machine learning can help the user. Additional use. For us, this small notion makes a big difference. In a highly dynamic and adaptive field like risk management and fraud prevention, we experienced that the best results are being achieved by a combination of a knowledge-based approach and ML-driven models. Knowledge-based methods like fuzzy logic-based scorecards, static and dynamic rule sets enables the analyst, the risk manager, to instantaneously react and adapt to changes to the environment. Next to this, it also allows to directly insert the knowledge he or she has in these areas directly into the system without having the need to enter into a bigger model training or evaluation process. And this is something not to be underestimated, especially when in an area like risk and fraud management. Just imagine that tomorrow there might be again a new payment method which might be launched. For instance, let's call it fancy pay or tomorrow pay. With a knowledge-based methods, we would be already able to add a base security line onto these new kind of payments by implementing rules, by applying profiling techniques, by putting the knowledge which we have or what we think, what might happen, what kind of attacks might follow into the system. Whereas if you only would rely on machine learning, you would most likely need to wait until sufficient amount of data from these new payment methods would have been gathered, um, sometimes including fraudulent ones, in order for the machine to learn the underlying pattern out of it. So this is something where we therefore believe in this combined usage of knowledge-based methods and machine learned models. If you now go for the next slide, um, therefore, that's the reason why we say we want to apply machine learning driven models typically as an addition to help to further fine-tune the results by assisting in detecting patterns potentially not directly seen by the analyst. It helps to better understand and evaluate the bigger picture. Thus, in most of our implementations, we decided to make use of the output delivered by machine learning driven models as an additional input to the knowledge base set in order to allow our users to reason about the judgment of the machine learning driven model and to decide for themselves if they want to follow the advice or if they want to overrule this in certain kind of decisions or in certain kind of situations. If we go to the next slide, uh, it's just to show you, and that's what we do within RiskShield. So we decided to combine the best of both worlds, like the knowledge-driven part in combination with the machine learned model. And this is where we experience that, let's say that we get better results out of making use of both worlds. If we go to the next slide, we may now ask, okay, but why did we now go for BigML when Rashid already had the capability of applying both? So like both words. The answer is quite simple. If we go for next one, please. Um, the core competence of RiskShield as a multi-purpose decision engine is the ability to easily and seamlessly connect to various data sources, to process and apply various rule sets and models in real time, memorize decisions, and be able to apply adaptive workflows depending on the outcome of an evaluation. Before partnering with BigAmel, before integrating BigAmel as an essential solution into our overall offering, Rashid was used for machine learning primarily as a decision engine, which allowed to gather and sanitize data, do feature engineering, and afterwards being able to apply models created in environments such as RStudio and Python. When we go for the next slide, so this was the way how we did it in the past, and we are still making use of these kind of techniques as well. But after having seen and experienced, let's say, the beauty of BigML, we decided to complement Rashid with this intuitive and user-friendly machine learning environment, which comes out of the box with different algorithms, enabling, and this was something which was very, let's say, a huge topic for us. We saw that it enables our customers who were non-data scientists for the majority to train, create, and validate models. So far, it was more like people were afraid machine learning. We want to use it, but we need to have a big group of data scientists working on this. And now with BigML, we saw, yes, it's still valid. You should have some data scientists, but it's not like that only data scientists can make use of this tool. And this was something very much important for us. When we go to the next slide, that's the reason why we decided to combine both tools. So to again offer a complete now tool set to our customers, which enables basically them to experience the beauty of machine learning in an integrated manner where current data will be used in combination with the feedback from our investigation process or from different kind of other data sets where we get feedback from the labels from, to train models which can be promoted with one click into production. And if you go to the next slide, basically this is what we today call and market under the name Rashid ML. So far now from the high level perspective. And now I would like to hand over to my colleague Kevin, who is one of our senior data scientists. Kevin will go now a bit more into deep and will give you insights into the smart algorithms being used within Rushfield ML. Kevin?
All right, thank you, Roy. So by now that everyone has understood what Rushfield ML is. It is a hybrid AI system made for fraud detection. But that is not the only thing that is important for us. And we had many evidence throughout the day and different talks that the world changes, and the world changes means that your algorithms has to change as well. So something that is smart and slick as a system, as a solution, has to learn and adapt to the world. But first things first, so as a data scientist, I've been also asked in a chat before, it is, from a data scientist point of view, what we need to do here is to build a so-called two-class classifier. So what does that mean? On one side here, we see on the left side, we make predictions, we give a label, we call it legal transactions or fraudulent transactions. Fraudulent transactions can, as Jan explained, result in generating cases where an analyst or an investigator has to go through all the cases and then check, are they really fraudulent, or are they actually legal transactions? So we're talking about the performance of your system in some point of view. And to do that, well, you can take your labels and then compare with the actual labels. And this results into something what you might know already by now in a confusion matrix. This is my take in presenting this confusion matrix. So the sizes of the boxes sort of represent the proportions. So you see, again, similar stories we had before. We have the imbalance situation, which is good, meaning that most of the transactions that you have in the world are legal. And there are those few ones, the nitty-picky difficult ones, but still there's a slight proportions of real fraudulent ones. This might change though in future due to the fact that we all now wear, as Roy explained, different smart phones or smart watches and whatnot in order to make payments. So people can now utilizing these technologies and mimic frauds and then try to test it out. So the proportion of fraud actions might increase. And the other thing that is important, what we also heard before, is that, well, you build a system, you come up with false positive, that these are false alerts, or missed alerts, which are the false negatives. So in this case here, let's assume this true positive means that we have one case out of 5 cases. So that means, well, the analyst has to go through 5 cases in order to find this real fraud ones, and then have to acknowledge that, well, all the other 4 cases, they were legal. That is okay if there are only 5 transactions, or sorry, 5 cases that you have to work through per day. Multiplied by 10 now, then we have a relation between 10 versus 40. So 50 cases I have to go through a day, which is still possible. But if you multiply this year more and more, then you can see that human resource is almost the limiting factor. So yes, your system can come up with these nice proportions here, but then it's business actually that sort of guide us as data science practitioner what the performance need to be. Maybe once you find all those fraud cases, and then you say, I have a cohort of people, they can work through the cases and then acknowledge or really confirm it is fraud. You can go the other way around and say, no, I want to see only the real fraud cases, but then you would sacrifice the missed alerts. So all these hidden fraud cases are not detected. Whatever you do, whatever business requires, The fact, though, is that we can't just sit on one model or a solution and then keep that static solution. And the reason is that the world changes. As we are now sitting in front of the laptop or whatever devices you use, we are all aware that we have COVID-19 going around. And as I've Googled around it a bit, my brother just called me a few days ago and asked, how's it going actually in Germany? Because here people are stockpiling as hell. And I didn't understand what he was talking about until I went myself to the supermarket and I saw, well, I didn't see just that here because people have stockpiled toilet papers already. And I didn't have a chance actually to get my lot. But what does it mean? The world changes, it always happens. The effect is that people respond to those changes. Either it's this incidence here with COVID-19, be it it's Black Friday, where people think, well, I'm making a bargain, so let's go shopping, or anything else. The world changes. In science, we call it concept drift, and then we have to adapt to it. These 4 icons sort of illustrates or simplifies what changes they are or how we can classify them. So if you take the left top one here, the horizontal axis could be the time, and then the vertical axis is some kind of data mean. Let's say it's your amount of money that you spend. So over the time, it's sort of constant. It doesn't really, the average amount is sort of, stable. At a certain moment, it jumps and then it changes and then it stays like this. Have you been hijacked? Have your account been hijacked? Have somebody just tried to use your account and then make payments? These are sudden changes that we have to respond to. The other types are, for example, this one here on the right top, which is an incremental change. So you get a stepwise change where you can follow how the world differentiates from the past. As well as on the left bottom here, we have recurring patterns. Could be a seasonal effect, something that happens during Christmas time. It's different than in summer, but it comes back again and again. As well as on the right bottom, where you have gradual changes. So it's sort of oscillating between different states. So it doesn't manifest state in one state yet, the new one, but it comes back a little bit and jumps and so forth, sort of not decided yet. But these are sort of the type of changes that we can face with and then can see in the data. And as Roy explained, the knowledge base component in RiskShield ML is something that is ideal for these sudden changes. Why? Because we can write rules instantaneously and adapt to the world. And in terms of banking, where someone might have compromised a point of sale or an ATM machine and whatnot, you want to act right now. Imagine someone just called you at 11 p.m. on a weekend and say, well, we got an incident, do something. You might not have the time to really retrain a new machine learning model and tune it, but you have to do something right now. The example that I want to show here is not necessarily a fraud attack, but I still explain the benefit why we use knowledge-based system as well as using ad hoc measures, that is writing rules. So bear with me with this example here. So suppose there's a person, Max Mustermann. He's a perfect German guy. He does a transaction, spends 20 euros at 10 a.m. in Germany. And then 1 hour later, he spends $30 US. Whoa, whoa, whoa. You might say, how is that possible? Common knowledge would say that it is impossible to travel somewhere in Europe, then to the US within 1 hour. That means that he would have traveled with Ironman speed almost 8,000 kilometers per hour. So using our knowledge, we can say, if your travel speed is too high, I want to issue the action decline. So that transaction is blocked. And that is makes perfect sense. And these are how routes can be generated and also prepare for future incidents. So you can, that is the beauty where you utilize expert knowledge and anticipate what can happen and then simply list them all up. Imagine now your bank opens another branch, perhaps has a new portfolio of people, and then now someone tells you, hey, all these alerts that I'm getting, they are false, they are not correct. So let's stick with this example here. What could have happened? Well, let's say Max is again going around, spends 20 euros somewhere at 10 a.m. and figured out it's somewhere in Germany. And then 1 hour later, he does that with spending another $30 in some kind of a bridge shop. It turns out that it is possible. And why is that? Well, I hope you can see this Google map here. This place where he spends the money is in a US Army base here, where I'm moving my mouse now across with. And it's obviously juxtaposed to another small town in Germany, where, in fact, yes, at 10 a.m. he can go there and pay with 20 euros, and then travel back to his base, and then go to another shop and spend another $30. So that is perfectly okay. And then this information, yes, it's possible to utilize machine learning to find that out, to reduce your false positives, but that is also, again, very difficult, and it requires some meta information. And the human can simply go ahead and say, well, I know that, and I can list all the other shops that are also in on this US military base. And then I can say, well, if your travel speed is high, but in fact you're part of this US complex, then I said, well, this is an exception, I accept it. I think I would leave out this ACDC example here. It's another fun story that I just heard from a customer. Perhaps someone wants to ask that later in a question in a chat. Okay, so we got these sun incidences, and we can utilize rule-based methods to adapt to changes in the world. But we can also utilize machine learning to adapt to other situations in the world. So what could that be? Well, again, Jan, you're right. Using these icons sort of simplifies how things are done in data science. Perhaps these are the new language instead of using pseudocodes. But the thing is, then we build models, what we call evolving models. What is that? Imagine we are in January, and then we have data from November and December. And basically, we're utilizing past or historic data and create a data source, generate a data set, and then build a model for prediction. Now, as it progresses, the world changes as well. And now we're in February. Instead of utilizing all the available data, we are deliberately moving the window forward. So that means that we're using now only December and January data, more, how should I say that, current or present data. Not all the data, but a subset of the data, the recent data. And we built another model. And this model hopefully would be much better in performance than utilizing all the data. What does that mean? So that means that evolving models has the concept of forgetting. So you're sort of giving a bias to certain data, historic data, not to old data, because they are only valid for the past, but for right now, different season, different trends in the world, they're not useful at all. In fact, they might create a too great of a variance in your data distribution, and that would hinder only your the performance of your model. Another sort of model that you can generate is an ensemble. An ensemble, in this sense, is that you have a set of historical data that you want to learn from, and then you define different window sizes, generate the model, make a prediction, and thereby creating sort of a library of models. Now, the world, as I said, changes, and not all those models might be suitable, maybe some of them in combinations. And what you can do is that using this ensemble of models, you create another, or you build another model, which is a logistic regression. So basically, you want to assign different weights to those predictions. And you want to update this logistic regression model. Why would you want to do that? Well, there might be recurrent events, so recurrent changes in your data. And the idea is that with this library of models, you believe that certain of these models are suitable for periods of your data, of your time series, or maybe for certain constellation of your data. Can also say that why not build simply a new set of ensembles and models? Well, they might not be necessary. And in fact, if you do it this way here, where you utilize a library of models, and then you figured out some of them are more legitimate or more useful now than later by using different weights, then you're already explaining something about the current situation, utilizing these models as a reference. We have conducted several proof of concept studies, and what I've told you about evolving models and dynamic ensembles is that what you also observe for these proof of concept studies, that it work very well, and we gather some experience in developing these models. And we are now rebuilding these models with BigAmel. And let me move forward to the next slide. And this slide here simply summarizes what I've said. You have a distribution of data, fine. The business tells you that I accept only a certain amount of false positive or false negative, meaning false alerts or missed alerts. And now this is the performance of a set of models. The world changes, the distribution changes, and that is no longer, let's say, handleable by business. It's all not acceptable anymore. So what you need to do, you have to adapt to the new world, make a transformation of the data, make a new set of models. So in a way that we go up the cycle, that you're back to this sort of distribution where business says, I accept only this rate of false positive, false negatives, and I anticipate these rate of true positives here, the real fraud cases. So the slide here is sort of to summarize a little bit what RiskShield represents. It is a comprehensive fraud engine. It has a high performance in terms of really processing transactions right on demand and high volume, utilizing rule sets or even machine learning models. And that is what we call a superior detection technology. It is adaptable and transparent. These rules are easy to write and code, and everyone can read it because it's really human readable. And it's also easy to implement new rules, be it in the rule set in RiskShield environment, as well as on a BigAmel side, because it is intuitive now to create models, and it's also easy. And overall, what is important in this area is agile optimization. Somehow we need to quickly adapt to the new world and come up with the best solution. So if we want to summarize things and then come up with a few take-home messages, these three would be those take-home messages. First of all, the financial crime environment is highly adaptable. We heard that from Michael Skiba. The combination of knowledge base and machine learning models delivers better results, and I hope we could give you some idea about that during our talk, as well as through Jan's talks. And as I said, the world changes, and then we need to find solutions to adapt to the new world, be it with knowledge base or machine learning. So that is what we call agile optimization. It has to be smart, rapid, and interactive. With that, Roy and I would like to thank you for your attention.